In this module, we'll learn all about value stream mapping. We'll start by going through a step-by-step guide of how to create a value stream map, understanding the different symbols and the process. We'll then finish by looking at an example of a real value stream map so you can see what the finished product looks like. Value stream maps are a really powerful tool and often people's first experience with Lean, understanding where they can get improvements. I hope you enjoy the module.
Mapping tools can be seen as meta tools in the sense that they should guide the use of other tools, but in isolation serve no purpose. At the end of the day, mapping itself adds no value without the follow-up of action. It does, however, paint a clear picture of a system with data and facts, enabling problems to become visible and a future should-be state visualized. The first point I will stress with value stream maps is that it is extremely important that the mapping operation is done as a team with the people from the Gemba. Value stream maps are all about understanding the real current state, even if it deviates from what managers or engineers originally designed or believe is the case. If you don't include the people from the Gemba, the map will be what we think or hope happens and not what really happens, and improvements could be missed or the system misinterpreted. I've come into many companies to find that they have a laminated, visually perfect value stream map that is inaccurate and created without the involvement of any frontline workers. This is not just a waste of time, but also a missed opportunity to gain involvement with the team. Value stream mapping will often be people's first experience with Lean and a brilliant opportunity to identify the changes that really make a difference. So let's not create these maps in isolation. Let's work with a team, use real data from the Gemba, and seek to truly understand how things are currently operating. Remember back to our first module, Lean is about reducing waste, maximizing customer value, and involving people. And if you've made an impact on each of these every day, then you're going in the right direction on your Lean journey. Value stream mapping relies on making assumptions with the aim of providing a big picture overview of the value stream, as opposed to a granular process level analysis. One assumption lies in the fact that a value stream map is a snapshot in time, when in reality the system is dynamic. For example, by using average values for stock levels, seasonal fluctuations will not become visible. The key with value stream mapping is knowing that it is an investigative tool that should be used to help spot areas that need further investigation or analysis. Value stream maps map the flow of products and information through your system, from the supplier all the way to your customer, including all processes within the scope. They also include transport between processes, inventory, work in progress, and data on the efficiency of each process. Value stream mapping uses many of the principles outlined in the visual management lecture, using a common language of symbols to allow easy communication and using colours wherever possible to make problems visible. Remember, problems are golden opportunities for improvement and should be seen in this way. The difference between a value stream map or a common process map is that a value stream map combines both the physical flow of material as well as the flow of information. By this I mean where the product physically moves to and from, and how the scheduling and information is passed onto each process. This will become a lot clearer later, but bear in mind that value stream maps are in two distinct parts: physical flows and information flows. This is what a value stream map visually looks like, and by the end of this module, you'll be able to create one similar for a system of your choice. Let's first go through the steps of value stream mapping, and then we'll run through a full example together. Much like many other Lean tools, value stream mapping follows 5 distinct steps. The methodology begins with defining the scope of your map and finishes with the creation of an improvement roadmap that defines how you're going to put into action what you have learnt. The first step involves defining the scope. What this means is to decide what we want to include within our VSM. It is near impossible and inefficient to map every single process, every different product variation, and every product combination. Let's first narrow our scope to ensure we're focusing on the product or product family that needs to be improved most. We do this by analysing data about your specific business and systems as a whole, with the aim to identify which parts are underperforming. For example, you may find that one product type has extremely low demand and perhaps in the future should be discontinued from the product line. In that case, there is little to no point in mapping the process, as future improvements may not even be made. Other insights could signify that one product type has a much larger lead time when compared to similar products, and data signifies that customers are very lead time sensitive. That may well suggest that the value stream map for that product would be a good one to start with. The key thing here is to question what the aim of the mapping is. What are the unknowns that you want to know, and where do you think you can make a significant transformation? Wherever possible, we suggest looking at the facts and making a data-driven decision for what product or product family to map, but in some cases it may be obvious where to start. Equally, if the majority of products follow a similar stream of processes, then it would be wise to map the most common flow of processes. Once you have decided on what value stream to map, you now need to decide the boundaries of that map. Within those boundaries should be areas within your team's control. This ensures that all suggested improvements can be acted on and you don't waste time on things out of your control. This is not to say that you should narrow your scope onto a single department, you just need to be realistic about what you have control over. Some companies that are very experienced with their lean journey may decide their boundary needs to be widened to map the supplier processes as well. Having narrowed the scope of the project, we can move on to step 2. Step 2 involves mapping your current state. This is the biggest and most time-consuming part of the process. This can be split into 2 separate sections. One is mapping the physical and information flow, and the second is gathering the specific data on each of the processes. Let's start with mapping the physical processes. Value stream maps use symbols to represent different parts of your system. It is important to understand the definition of these symbols, and by the end you should be able to read a value stream map, almost like a sheet of music, knowing exactly what the map means. Firstly, you have the production controller. This is represented by a rectangle and is the central production scheduling or control department or person. Next you have the customer and supplier, represented by a little factory-looking shape. This is usually the starting and ending point of the material and information flow. Then you have inventory, represented by a triangle, with the size of inventory written either in or below the triangle. Next you have shipments. These are used to represent material flow from, into or out of a system, i.e. from the supplier or to the customer. For internal material flow, you use a striped or barred arrow. Next we have information flow, and this is a jagged arrow, and it's for electrical information flow, while a straight or right-angled arrow is for manual information flow. A dashed line is used to show a pull signal of information through a pull system. Now we move on to 3 related symbols. FIFO, which means first in, first out, supermarkets, and Kanban. FIFO is a way to make sure that stock doesn't go out of date or that work is distributed fairly. It is most commonly used in a FIFO lane, where items in a lane are taken at one end and supplied from the other end. You will have seen this in the bread aisle in your local supermarket. You take or pull bread from the bottom as you need it, and they restock it from the top. Of course, this is the best way to avoid stale old bread, but it also might be the best way to delegate work. It might be the order in which you prepare food in after taking a customer's request in a drive-through. The main idea is that the item is pulled only as it is needed, and an empty space in the FIFO lane triggers the need for the item to be replaced by the previous process. FIFO has a set maximum level and acts as a controlled buffer for processes that vary in cycle time. Another similar theme to FIFO is the supermarket. We'll talk a lot more about supermarkets in other modules, but for now it is important to understand what they are, so we can understand when to use the symbol. A supermarket is a predetermined, standard inventory that is kept to supply the downstream processes in exact amounts. It can be viewed almost like multiple FIFO lanes, all containing different products and different quantities. For example, if a doctor used 10 vials of medicine at a time in one operation, we might keep 10 of that particular medicine in one place so the doctor could take that exact amount for each operation. When that box is taken, it will trigger us to replace it with another pre-made box of 10. The way in which this signal to replace the consumed boxes is sent is by something called Kanban. Again, we will explain this more in other modules, but for now you need to understand that Kanban means signal and normally takes the form of a physical trigger using a card containing the information to be replenished. For example, if a supermarket of products reaches a defined replenishment level, it will trigger a Kanban card to be sent upstream. Process 1, for example, is sent a signal to produce 4 blue circles, which proceeds through the system and replenishes the finished stock. The Kanban card is then returned to the supermarket and the cycle is ready again. For Kanban, you need to know the 2 symbols shown on the screen. The first is the Kanban card itself with the information, and the second is the point that it is received. This will all be clear a lot later when we go through an example. Back to the symbols. We use a circular arrow to show a process taking stock from the supermarket. Finally, we have the actual processes. They are represented with a rectangle with a header which names the process. They come in 2 forms. One is the simple box, which only contains the time taken for the process. The second form is a shared process, a process which multiple value streams use. And finally, we have any process that is inspection, and also data boxes that provide more information on each process. And that concludes all the symbols that you need to know. This may seem like a lot of information to learn, but once you start to use the symbols, you will find they are actually quite easy to remember. Also, you are not expected to learn off by heart all of the symbols. When it comes to practically applying what you have learnt, you can print off the attached Word file which explains each symbol and take it around your work environment with you. Once the symbols have been understood, we now need to go to the Gemba, and we highly recommend commencing your mapping at the end of your value stream, the point at which your product is being shipped to your customer, or the furthest point downstream within your scope. The reason for this is often people have preconceptions of where material flows and how products come together, and by starting at the end of your value stream, these assumptions become eliminated. A good way of thinking about this is with the alphabet. When you go through the alphabet in its normal order, from A to Z, you are on autopilot and don't have to think about each letter, whereas when you go backwards, you need to think about each letter and follow it back. The same is with process mapping. By following it backwards, it's much harder to make incorrect assumptions or jump to conclusions. So, starting at the end of your system, you simply walk back to the front, identifying the flow into and out of each process, categorizing them as value add or non-value add. Record the stock levels before and after each process, and understand where the information flows from. This should allow you to start to draw the skeleton of the map, adding the meat later in the form of data. When mapping the value stream, be vigilant and ask the operators or team leaders if you're ever unsure. It is important that the information and flow of processes is accurate and no assumptions are made. Often the way things are done is different to what you always thought or how they were meant to be done. You should continue doing this, moving upstream, until you reach the start of your value stream, which is either the arrival of deliveries at goods in or at the edge of your scope. By the end of the mapping, you should have a skeleton of the value stream map showing the flow of value through the system. It may look something like this. Next, we move on to the second section of the current state map. This is gathering the data for each process. While we were investigating the flow, our aim was to understand the sequence of processes. Now we need to look into the details of each process. For each process, we need the following fields to be populated: process time, value add time, non-value add time, changeover time, batch size, number of operators, and reliability data, which could be mean time between failures and mean time to repair. Additionally, the rework percentage should be filled in. The best way to complete this is to print off a datasheet with all the fields in and try to fill in as much as possible at each process. A template has been attached for you, so you don't need to create one yourself. An important thing to mention here is how you take this data, as it's quite rare something like value add time or percentage is available easily, and therefore you need to work it out. Here, your best option is to complete a spaghetti diagram for the process. This not only provides the value add percentage, but also provides other information that will be useful for the value stream map. Otherwise, a simple time study for each process can be completed, where you split the process into tasks, measure how long each takes, and designate each task as value add or non-value add. Think back to the flat pack assembly example in the wastes module. It's exactly like this. Now it's time to combine both the process map and the data together. This is similar in nature to how an investigator collects facts, pictures and evidence and places them onto a board. The red string symbolises the value stream map, the skeleton, and evidence is the data boxes that will help crack the case and find the opportunities for improvement. When constructing the value stream map, I suggest doing so on a large wall, as they take up a lot of room. Another tip is to line the wall with wrapping paper or brown paper so it's easy to take down and fold up at the end. I would highly recommend using post-it notes on the paper so you can easily move things around. Starting from the end of your process, place the correct symbols on a post-it note and onto the wall. Moving upstream, use the symbols to visualise the flow into each of the process and how long the process takes. As you continue moving up and placing process symbols, flow symbols and inventory symbols on the wall, you'll build up your map. If there are any parts of the map that you have missed, make sure you go back to the Gemba and find the answer. An inaccurate map here will really hinder you later. Place the data boxes under the related processes. You now have a map of your whole value stream. From here we start to calculate some metrics on the system as a whole. First we create something called a lead time graph. Along the bottom of our map, aligned with each process, we want a graph with time on the x-axis and value add on the y-axis. The lead time graph is a great visual way of demonstrating how much of the process is value adding and how much isn't. To do this, you need to convert inventory into an associated time unit. For example, if there is a stock of 500 units before process B, and the cycle time of process B is 3 minutes, then the inventory time is 500 times by 3, which is 1500 minutes. If you cast your mind back to the flow module, in order to calculate lead time, you need to work out how long it takes a single product to flow through the system, as if you were putting a camera on the product and following it through the value stream. With that in mind, if you put a camera onto a product that has just finished process A, it will have to wait 1500 minutes until it's finally processed at process B. You continue to do this throughout the value stream and end up with the graph shown below. Once this has been completed, the total value add percentage of your system can then be calculated by adding all the process times together and dividing it by the total lead time. Remember, the total lead time is the inventory times plus the processing times combined. In this case, there is about 38 minutes of value add and a lead time of 43,000 minutes, creating a value add percentage of 0.09%, meaning if you put a camera on the product, it would only be worked on for roughly 1 in every 1,000 minutes, or roughly 1 minute per day on average. These numbers may shock some of you, but many companies I've worked with have a value well under 1%. Now we have a picture of our system as a whole with a value add percentage completed. It's worth spending some time here with the team reflecting on the value stream map and talking through the process from start to finish. This should include everything your business does to generate value for the customer in one simple picture. Next will be the part where we discuss only problems within this value stream map. What problems do we have with the current way of working? The key here is not to jump to a solution yet. We only want to hear about problems. Using a different colour post-it note, whether that be red or pink to signify a problem, write any significant wastes or problems above each process, and any non-process specific problems in a separate area. Using a combination of experience, the data boxes, and direct observations at the Gemba, all problems can be gathered here together. Examples could include things like high levels of rework, long changeovers, or double handling waste, etc. When writing problems, always support opinions with data and facts, and if you don't have them at hand, go to the Gemba and record them, or find someone that does have them. This is extremely important. Without the use of data, we cannot compare the severity of problems and distinguish between priorities. As famously said by Deming, an American statistician, quality guru and master of problem solving, "In God we trust, all others must bring data." In other words, without data, you're just another person with an opinion. As a last resort, asking team members or supervisors questions like, out of 100, how many products require reworking? This will give a better picture than just high level of rework with no support. However, do make any estimates clear by using an asterisk. And there you have step 2 of the whole process, mapping the current state. By far the longest and most difficult step. But you should now have a good understanding of your system as a whole and in a perfect position to start making improvements. The wastes in your system are likely becoming quite apparent, and you may have already thought of some improvement ideas. It's important to fight your natural urge to jump to conclusions, trust the process, and move on to step 3. Step 3 involves mapping your future state. For this step, you want to try and ignore all the previous work completed in step 2 and take a fresh approach. With a clean slate, the idea is to build a value stream that maximizes value-adding processes and minimizes Muda, Mura, and Muri. Think back to the change management module. The key here is to have no preconceptions and break any current paradigms. Anything is possible. This is your chance to paint the future for how you'd like it. If you can eliminate a process, change the order things take place, or implement a new system, then this is where that comes in. When putting this future state map together, you will often find the map is much smaller and simpler than your current state map and way of working. That is completely fine and a sign that you're on the right track. With the new way of working, what is the minimum stock that can be held at each process? Is it possible to work in single piece flow? Like the current state map, start with the skeleton for the process flows, then start putting meat on the bones with data. Finally, you need to document the solutions that you have devised and put them as green post-it notes onto the future state map. This makes sure when you start consolidating all improvements, none of them are forgotten. Now that we have 2 VSMs complete, the current state and the future state, this is where we compare the 2 maps side by side to ensure we have included everything we need to do to get the current state to the future state. This is like a game of spot the difference. Once the game of spot the difference has been completed, every red post-it, i.e. problem, that has been identified in the current state needs to have an associated solution made. We can now move on to step 4. So what we've done is we've mapped the current state, the future state, and identified all the improvements required to move from the current state to the future state. Step 4 is where we compare all the improvement opportunities to ensure that we start working on the biggest bang for our buck project. Return on investment is pretty self-explanatory. It's the gain from an improvement divided by the input required. You should do rough calculations on how much value an improvement will bring, and rough projections on how long it could take and how much it will cost. For the purpose of this exercise, this is not about getting an exact value. It is used primarily as a prioritization tool to compare different improvement initiatives with each other. In order to help visualize the relationship between return and investment, each improvement initiative can be placed on a return and investment graph. The graph is split into 4 different quadrants. The bottom right are the ones with the least return on investment and should be picked as the lowest priority, while the ones in the top left quadrant demonstrate the low-hanging fruit, the projects with high return and little investment. As with everything we do, we need to make a logical decision as to what to spend resource and focus on to achieve the greatest results. By working from the top left quadrant towards the bottom right in a diagonal fashion, each project can be ordered based on their return on investment. This means that later on, when creating the improvement roadmap, you can easily decide what to prioritise. So now that we have compared our future state map with our current way of working, we've identified our improvement opportunities and calculated the return on investment for each improvement. We now need to create a roadmap for implementation. In this step, we will lay out exactly how we plan to achieve our goals within an action plan. This is not quite as simple as sequencing the improvement projects in order from high return on investment to low return on investment. Other considerations need to be made. For example, what is the most logical order to implement these actions? Does one solution require a previous solution beforehand? Or is there a planned shutdown or period in the year that would make much more sense to carry out the bigger projects? Every company is different, so this is where you start filling up your calendar. Allocating a project owner is extremely important to ensure responsibility and accountability for each improvement that has been made. Project durations need to be estimated and proposed completion dates selected. And this is a step-by-step guide to conducting a value stream mapping exercise. Now that everything is in place, it's time for the real hard work, the implementation. Before we go through a completed, full example of a value stream map, I would like to say that although it may appear a lot of work, it doesn't need to be completed on a frequent basis. Often companies will conduct an activity like this once or maybe twice per year as a means to help identify the next lot of improvements. Also, once you've done it once, you have a previously completed future state map to hopefully replace the new current state map, or at the very least, you can see the progression of the business and value stream through time. Okay, so let's now work through an example.